Hi everyone. This video here is just to supplement the fact that we had our problems with the installed version of pytest on the CSE machines, which meant that we had to kind of cut our example short in the Thursday lecture of week 1. So this is kind of where we got up to in the Thursday lecture of week 1. Pretty much just talked about pytest. It's a Python module. Normally, if you're on your own computer, you'll have to do some installs and stuff, but on the CSE machines, everything's already set up. So there's huge amounts of documentation for it online. This is the actual website here, but you don't need to worry too much about that. The kind of crux of pytest is that you can write tests throughout your code, just like you would if it was without a library. You just write tests with asserts and stuff, except what pytest allows you to do mainly is to control which ones you run and how you run them a bit easier. So for instance, the third point here is pytest detects any function prefixed with test underscore and runs that function. So you don't even have to specify which tests run. And obviously there's much more to that than just this particular rule here. But yeah, if we have a look at the examples, so on the left here, this is what we would run if we were just writing Python without any help. So we've got this file here, test1 no pytest. You can see we have some sums there. Let me just quickly navigate to the folder. And then if we want to run it python3 test1 no pytest. And you can see the assertion error there is triggered. Now, if I open pytest, and you can see the difference between these two is that the pytest one imports pytest because we use it, and you also notice that we don't actually call our test function as part of our file. We invoke pytest. Now, by the time you are reading this again, this won't say py.test, it will just say pytest. So something like this, pytest-3, and then we call it with our file test1 pytest, like this. So you can see what pytest has done here is it's actually opened your file and just having a look here. Yeah, so it's opened your file and it has seen that there is a function called test. In this case, it doesn't need to have the underscore. I think that was just a typo, but usually it's good to have it. So we have something like this, test1 underscore sum1. So you can see that pytest has gone in and gotten this test function. It's ignored the sum function because it doesn't start with test. So this is one really convenient thing about pytest, is that you don't have to write a list of which functions to call. You don't have to necessarily separate out your files as much if you don't want to. It's just a lot easier to write these tests knowing that pytest will run them. So you can see that it fails and it tells you where it failed. You can see that because we put this string here, that helps us actually debug it when we look at it, because you can see here, assertion error, 1 + 2 = 3. Great, so we know what actually went wrong there. So if we fix up our sum function and make it a plus instead of a multiply, we run it again, you'll see that pytest successfully succeeds. So these first two lines of pytest here, this is just it running. You don't need to worry about them. Then it tells you how many tests it collected. And this is the interesting part. So for each file that you run pytest on, it will print out the file name and then it will print out something, and it will print out many of these things. So if I had another couple of tests here, such as test sum2, test sum3, and we just did different numbers, right? Like 4, 7, should be 8, should be 5, right? So 4, 7, sorry. And this is 5, and this is 8. And then we rerun this with test sum1, test sum2, and test sum3. See how it's got 3 dots here now instead of 1? So that's just part of pytest syntax. So what it does is it prints out a dot for every test that runs and succeeds. That just helps you visually keep track of it. And you'll see if a test fails, so I'll write a bad test here, expecting 1 + 6 = 8. And you can see that pytest now, instead of saying 3 dots, it did ... f. So that succeed, fail, and then it shows you where it failed. Now, you can see that in this case we have our 3 tests actually succeeding. If we change this back to a multiply sign, you'll see that they will now all fail. FFF, and you will get errors for each. So that's a very handy way to, yeah, essentially follow what's happening. And you can see that's just how easy writing the tests were. We did not have to specify to run those functions. It just ran them for us. If we wrote another function called like def multiply xy, pytest will just ignore this because it does not start or end with test. So pretty easy. Now, oops, all right. So the next thing is looking at a bit more of a complicated file. So let's go and have a look at, let's open testmultiple.py, right? Testmultiple.py. Now, it's a bit, you can see some of these lines down the bottom have very large sums. And you can see that when we run this one, so if we run pytest3, pytest-3, test multiple, that's similar to our ones before. It runs 3 tests. Notice that it's actually doing 8 asserts though, right? Because we have 3 asserts in one test, 3 asserts in another test, and then 2 asserts in another. So that number of dots there is not the number of asserts or number of checks that were made, it's the number of tests that were passed. And tests consist of potentially multiple checks, multiple asserts. So that's pretty straightforward to understand. That's just that you can use it you know, with more things. You notice that if we change the names of our files called like check large, you'll notice that it will now only test 2. Watch these dots down here. It will only test 2 instead of 3. Right? That's because pytest does not pick up on it. You'll also notice if we write large test that pytest will pick up on it because it ends with test. Oh, it should. I guess in this case it didn't. Has to start. Oh yeah, has to start with test. Sorry, I'm thinking about file names here. So yeah, all of your tests have to start with test underscore. I think we saw before it works without the underscore part as well. So it doesn't have to. It could be, you know, yeah, it just doesn't have to have that underscore there. That's more like when we say the underscore there. That's more because it makes it much more readable, and it's also a bit more standard convention, just because obviously people want to see an underscore there. And you'll see in lots of projects as well, even if people are using camel case for function names like def add name, when they then go and do a test, they will often do something like this, because that underscore there makes it also very clear, whereas when you have camel case stuff, it gets a bit hard to see. Like to separate out your tests and not tests there becomes a bit challenging to read. So yeah, we have another test running. Now, I read the slide wrong before. So just because it looks for functions that start with the word test, the files, it'll look for files that begin with test or end with test. So in this case, if we look in this directory, you can see that we have a few files here. We have point change underscore test and test underscore multiple. So 2 different files with different ways of starting. So if I just run pytest-3 without any parameters, you can see that what it's actually done, we'll get to this function in a second, but what it's actually done is it's gone into the local directory and it has found every file that starts with test underscore or ends with underscore test, and it has automatically run it. This is another advantage of pytest in the sense that every time you add a new test file as well as a function, you don't need to add it to some kind of index or list for pytest to detect. Pytest will automatically just go and find those for you. And that's very handy. So now just to look at some even more specific examples. So if we go back to our previous one where we were testing test multiple, you can see that it's running 3 tests there. So what we can do is use a -k argument if we want to look for particular function patterns, function name patterns. So you see in this test file here, we've got test small, negative, and test large. If we only want to test the test small ones, we can add a -k and then give it an argument. So pytest -k small. Remember, so -k and small are tied together here, and then test multiple. And when we run that, you'll see that it only ran 2 tests. Now, if we want to see what 2 tests it run, we can also add another flag to the command, and this flag doesn't have an argument. That's why we don't need anything after it, right? It's just -v. That's different to -k here, which needs an argument, which is a certain string. So we do -v. V is verbose. Verbose means wordy. So it's the opposite of concise or compact. So if we do -v, you'll see that it gives us more than these dots now. It actually shows us the file and then the function that was run in the file. So you can see again, if we do -k, if we only want to do tests that test negative sums, it'll only call tests more negative. So that's where -k is very handy. So when you're designing tests, if you feel it appropriate, you can obviously design certain test names and test particular subsets of your full testing suite. Yes. So the last, I mean, this isn't something super short, but the last thing that we immediately want to teach you about pytest right now is markers. So markers are ways of using Python decorators to add more information. So we just talked about how we could use function names to actually kind of give more detail about what the test entails. But in this case, we actually want to use... so decorators aren't something you would have really come across, but essentially in a lot of high-level programming languages, above function names, you can use an @ symbol and then give it some information. And that's just, the reason they call it a decorator is because it's a bit like you have a cake and you decorate it with some sprinkles or some icing. It's just a little bit on top that adds to it, and this is the same thing here. So we just have a function, and then this decorator up here is just, it's essentially just a piece of text that means something to someone using the function. We won't go into much detail about that now, but you can use it. So there's a few things to these Python decorators that I want to talk about. I just want to open this file. I have to remember this is called point change. So if we open point change test. So what our point change function does is it takes in a point, which is a tuple of two variables, x and y, and it takes in a change, which is a certain increment or decrement, right? It's basically a positive or negative number. So we take the tuple, destructure it, add the change amount to each x and y coordinate, and then we return a new tuple that we've created. Now the thing is, when you test this, you could imagine that what's going to happen is a lot of your tests are going to want particular functions to set them up, right? Because a lot of your tests will involve setup. So you imagine in nearly all test environments, usually there's some kind of setup involved. If you think back to linked lists in 1511, you'll know that you often have to actually create the linked list before you can test removing it or something like that. So one thing we can do with pytest is add a fixture, and a fixture is essentially something that helps us with setup. So I've got this function here called supply point, and all it does is returns a tuple 1, 2. Now when I'm then writing tests, and you can see that I've got two tests here, test 1, test 2, and screw it, test 3 as well. Compared to the other tests I was writing, I'm actually going to give the function a single argument, a single parameter, sorry, which it'll take in. And this parameter that it takes in is a function name. So this is a little bit weird, particularly for people that have only programmed in C. I'm not going to try and explain the syntax too much because it is a bit gobbledygook to understand, but essentially if your test gets given a function, and that function itself is a pytest fixture, it will do that setup for you. And you can pretty much just kind of copy and paste this pattern and read more about it on the internet. But essentially what we're doing now is for test 1, we're asserting that when you call point change on point 1, 2, with change argument 1, that the result should be 2, 3. Now that makes sense. If you take point 1, 2 and you add 1 to it, you get 2, 3, and that's a fairly simple assert. And then under here, test 2 is pretty much just doing the same thing, except it's adding 5 to it, and test 3, it's adding 100 to it, and we get 101, 102. Now, we talked before about how we could add stuff to the names of these functions, so call them like test1 up. I use the word up to describe that the value is going up, like we're adding a positive number to it. So you could call it like test underscore up underscore 1, test underscore up underscore 2, test underscore up underscore 3. You could do things like that, but in this case, I just want to show you how we can use markers to have the same effect without locking ourselves into how we're naming functions. So you can see I've got pytest.mark.up. So what this allows me to do later is essentially group all of these functions together. So all of these three different functions here with different names, I've decorated with pytest.mark.up. So pytest is obvious, that's what pytest is. Mark is a reserved word to refer to marker, and then up is your word. So we control this up part. We don't control this pytest.mark part, we just control this up part. And then you can see we've also got these pytest.mark.down one here, which takes in a negative number. So that's how we distinguish them. Now, if we want to run these, that should be pretty straightforward as well. I believe it's just pytest3, and then you give it your point change name file. And then what we can do is we can give it, I think it's -m, I'll have to look this up, -m of up, maybe? Yeah, so -m means marker, and up is the word. So when you say -m up, it says go and get all my pytests with marker of up, and then it runs those, and that's why it ran 3. And you can also see if we give a -m of down, we have one function here with down, and we run that one. You can see compared to the first one where it ran 3 tests here, it only ran 1 now. So that's how we can, it's another way of controlling it. Another thing you can do, these are just 2 other little tidbits of information for you, is that when you write a test, you can also mark it with skip if you want. This is kind of the equivalent of commenting out the code. So say you write a test, but you don't want to test with it right now, instead of commenting it out, you can do pytest.mark.skip as a decorator. And pytest will see that and it won't run it. And then the other case is pytest.mark.xfail, which means exclude fail. And this is essentially where pytest will see your test, it will run your test, but it will not kind of give you an error message if it fails. So by exclude fail, we mean if it fails, just exclude this. And you can see that if I run pytest on point change test without any extra parameters on command line, that you can see it tests here up, it tests up, 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 down, and then this is the one it skipped, and then this is the one it excluded. So that's how these little dots and S's and X come up. That's just pytest syntax for you. And again, if I added the -v verbose to it, you can see same thing here, pass, skipped, xfail. And you can see that false equals true here obviously fails, because if you try and assert that false equals true, it's always going to fail. And yeah, that's why it got exclude fail. So if I commented this out, you'd see that now if I run it, we'd actually get an explicit fail because it wasn't excluded. Now you might be asking, why would we want to skip a test instead of commenting it out? There's a few reasons for that, but one of the best examples I could give you is that nowadays when people submit code to big repositories, quite often what you see happening is there's certain scripts that run before your code gets pushed to Git, where it will actually go through and look at the style of your code. And if the style of your code is bad, it will give you an error and ask you to fix it, or in some cases it will automatically fix it. When code's commented out, these linters, what they're called, they can't actually check it. So using pytest decorators to skip is actually a good way of ensuring that your code is still kind of readable in the repo, that it's still examinable, or it can be analyzed by any Git scripts, but it doesn't actually execute anything. So it's a cool little thing, but there's a lot to pytest. There's a hell of a lot more than I've talked about here, and you can see it all online if you just go to like the link we put in the lecture slides. There's like tons of stuff, and you'll find lots of other resources online. Generally, this is enough for most of you to start writing tests for the project, and then if you have any other curiosities, we can go from there. So I hope that fills you in on pytest.